Welcome to Spelling Bee Ninja, where we dive deep into fascinating educational topics. If you're eager to enhance your knowledge and skills, make sure to subscribe to our podcast for free educational content designed just for you. Today, we're exploring the world of right triangles and the Pythagorean Theorem, a concept that's not only a fundamental part of mathematics but also a tool that has transformed various fields from architecture to science. Let's get started. The Pythagorean theorem is one of the cornerstones of geometry, forming the basis for our understanding of right triangles. So, what exactly is this theorem? It describes the relationship between the sides of a right triangle, specifically, that in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the other two sides. This can be mathematically expressed as a squared plus b squared equals c squared, where c is the hypotenuse, the longest side, while a and b are the other two sides or legs. What's fascinating about this theorem is that it has been known for centuries. Although named after the ancient Greek mathematician Pythagoras, evidence suggests that it was recognized by earlier civilizations such as the Babylonians and Indians. Pythagoras, however, is credited with providing the first formal proof of this relationship, which has made it one of the most famous formulas in all of mathematics. Beyond just numbers, this theorem affects many aspects of our lives. Consider construction and architecture. When builders create right angles, they often rely on the principles of the Pythagorean theorem to ensure stability and precision. Straight angles provide a solid foundation, allowing structures to stand tall and safe. Furthermore, we see right triangles frequently in various fields including physics, engineering, and even navigation. Did you know that the ancient Egyptians used right triangles when constructing pyramids? They would create perfect right angles using ropes tied with knots. This practical application demonstrates that mathematics is more than just abstract numbers, it's a tool that has been significantly employed across different cultures and eras. Now, let's examine what constitutes a right triangle. A right triangle is defined as a triangle that contains one angle measuring exactly 90 degrees, referred to as a right angle. The side opposite this angle, known as the hypotenuse, is always the longest side of the triangle. The other two sides are referred to as the legs. Right triangles are particularly special because they allow mathematicians and builders to utilize the Pythagorean theorem, enabling them to calculate distances and solve various geometric problems. Understanding right triangles becomes crucial when planning structures as it provides the formula needed to accurately measure lengths and distances. To find the hypotenuse, you can use the equation c equals the square root of a squared plus b squared. This equation is not just theoretical, it has practical applications in real life. For instance, if one leg measures 3 units and the other leg measures 4 units, you simply plug those values into the equation to determine the hypotenuse, c equals the square root of 3 squared plus 4 squared. This results in the hypotenuse being 5 units long. This specific case provides a classic example known as the 3-4-5 triangle, which has been utilized for millennia as a simple and effective way to ensure right angles are created accurately. Understanding how to calculate the hypotenuse is vital across numerous professional fields. Navigating construction sites, designing ramps, or calculating the shortest distance across a park all can benefit from knowing how to determine the length of the hypotenuse using the Pythagorean theorem. Now consider the scenario when we need to find one of the legs of a right triangle when the hypotenuse and one leg are known. You can find a missing leg using the formula b equals the square root of c squared minus a squared. For instance, if we know the hypotenuse is 13 units and one leg is 5 units, we substitute those values into the formula to find the other leg, in this case, 12 units. This scenario illustrates another famous example connected to the Pythagorean theorem, known as the 5-12-13 triangle, reflects the beauty of Pythagorean triples. These triples are sets of 3 positive integers that satisfy the condition of a squared plus b squared equals c squared. The most well-known Pythagorean triple is 3, 4, and 5, where 3 squared plus 4 squared equals 5 squared. Other examples include the sets 5, 12, 13, and 8, 15, 17. The remarkable aspect of these triples is that they can be used in practical applications. Construction workers can create right angles using these measurements without needing to measure out exact angles. This knowledge remains indispensable for builders and engineers today. Let's shift gears to the real-world applications of the Pythagorean theorem that are so vital in our everyday lives. From the construction of buildings, where the theorem ensures structures are secured properly, to navigation, where sailors and pilots calculate distances, the theorem is everywhere. For example, in sports, coaches analyze trajectories and angles to strategize plays. In the realm of technology, the theorem plays an essential role in computer graphics to calculate the distance between pixels or render three-dimensional objects. Even something as simple as determining the length of a ladder needed to reach a specific height employs the Pythagorean theorem in its calculations. The theorem's impact reaches far and wide, making it one of the most significant principles in all mathematics. Now, you might ask, what happens if we have an unknown triangle and wish to understand whether it is a right triangle or not? That's where the converse of the Pythagorean theorem comes into play. The converse tells us that if the square of the longest side of a triangle equals the sum of the squares of the other two sides, then that triangle must indeed be a right triangle. For example, in a triangle with sides 6, 8, and 10, by calculating 6 squared plus 8 squared to see if it equals 10 squared, you will find that this condition holds true, confirming it is a right triangle. Interestingly, surveyors use this principle as a tool for checking right angles during their measurements. Diving deeper, let's explore the distance formula, which is derived directly from the Pythagorean theorem. This formula calculates the distance between 2 points in a coordinate plane. The distance is given as the square root of the difference in x coordinates squared plus the difference in y coordinates squared. By visualizing the 2 points as forming a right triangle with the horizontal and vertical differences as the legs, the hypotenuse holds the key to determining the distance between those 2 points. This profound connection reveals that the Pythagorean theorem is not limited to triangles but extends seamlessly into algebra and coordinate geometry. It's an essential aspect of mathematical understanding that supports a range of higher concepts, from calculus to statistics. The beauty of the Pythagorean theorem lies in its simplicity and its profound significance across various aspects of mathematics and science. It serves as a crucial link between geometry and algebra, playing a foundational role in trigonometry and calculus, while permeating through nearly every branch of science and engineering. From the constructions by ancient surveyors to applications in modern physics, this theorem offers valuable insights into distances, shapes, and the structure of space itself. The theorem's importance is further exemplified by its extensive proofs. There have been more than 400 unique proofs established over centuries by mathematicians, including a proof attributed to a U.S. President, James Garfield. The legacy of the Pythagorean theorem remains not only a testament to ancient inquiries into mathematics but also as a principal framework for understanding our modern world. As we wrap up this exploration into the Pythagorean theorem, we've discovered its significance in the world of mathematics through its relationship with right triangles. We learned how this theorem allows us to calculate the hypotenuse, find missing sides, and understand the practical applications in various fields including construction, navigation, and sports. The theorem serves as a bridge connecting geometry and algebra, embodying a rich history of mathematical inquiry. It is no exaggeration to say that the Pythagorean theorem has shaped our understanding of geometry and continues to be essential in modern science and engineering. Thank you for listening to this episode on the Pythagorean theorem. Remember, mathematics is all around us, and understanding its principles can empower us in countless ways. If you've enjoyed this journey, don't forget to subscribe to Spelling Bee Ninja for more engaging educational content. Stay curious and keep exploring the fascinating world of math. Until next time.